Good day to all. I am Ramya Rose, Assistant Professor, Department of Artificial Intelligence and Machine Learning, RMD Engineering College. This video, we are going to see a topic under the subject database management system with the subject code 21IT403. And the topic is going to be entity relationship model, ER model. So before going in depth with the topic, first we have to know what is the model, data modeling, or what is a model is. Before we work into something in depth or before we create something, we are making a model or sample or prototype or a blueprint of which so that we get more idea on what we are developing. So when we are working on databases, before developing the original structure of the database, we are going to make some diagrammatic representation of that particular database, showcasing what are all the entities or who are all the users going to participate, what are all the different actions going to take place, how one person is connected to the other person, or how one information is connected to the other information, and so on. So ER model is going to be a diagrammatic representation which is going to focus on the total structure of a database. So before developing it or before designing a database, we are going to make samples or diagrammatic representations showcasing the original structure of that particular database. So now, to begin with database ER diagram, you'll have to know the meaning of what is entity and what is relationship. So ER stands for entity relationship model. So entity is nothing but any real world thing. So it could be a person, it could be a company, it could be an event, it could be an action or anything. So if I say a classroom, in that entity could be a faculty, entity could be a student, entity could be a test scheduled, entity could be the attendance maintained, anything, any real life thing that is going to be connected with us is an entity. So entity set is going to be some set of information put together that has some specific characteristics. So now, with the help of these many entities put together and with the relationship among the different entities, how a diagram is drawn or how the diagram could depict the original structure of database that we are going to see in this topic. So ER model, as I told you earlier, is a diagrammatic representation which is going to express the database graphically. So to know about ER model or to make a better ER diagram, you'll have to know about what is an entity and entity set. You'll have to know about a relationship. You'll have to know about attributes. You'll have to know about roles. And you will have to know about constraints. Constraints, we have got two types of constraints, mapping cardinalities and participation constraint. We'll see everything in depth. Now, I told you earlier, entity is any real world thing. It is not fixed that it should be only a person. No, it could be an action too. It could be a company or whatever it is. So, example I told you earlier. So it could be a person, be it student or a staff, or it could be the action involved in that particular class and so on. So consider this as an entity. So instructor is an entity and the student is an entity. So now instructor has got two information to describe that instructor. So one is the ID and the other one is the name. So here the ID and the name are going to be two attributes that is going to describe that particular entity. So three things you will have to know when you are drawing entity relationship diagram. What is an entity? What is a relationship? And what is an attribute? See, attribute is nothing but the characteristics of that particular entity or anything that is going to describe that particular entity, you call it as an attribute. So when I say about instructor as an entity, the ID as well as the name is the attribute. So diagrammatically, so this is actually a table format. When I could mention it as a diagram or in an entity relationship model, every entity is represented in the form of a rectangular box with the name engraved in it, showcasing that this is an entity instructor, this is the entity student. Now I told you every entity will have different attributes which is going to tell about that particular entity. Say, for example, if I want to describe about a student, the student will have his or her own name, number, register number, a mobile number, email ID, and gender, date of birth, his own CGPA, individual marks of subjects, and so on. So all these things which is going to describe that particular entity, you call it as an attribute. So we have got different types of attribute, the simple and composite attribute. single valued and multi-valued attribute, derived attributes, and domain attributes. So simple and composite, how it could be differentiated is simple valued attribute is something which cannot be divided. Say for example, date of birth. Say for example, register number, which cannot be divided. But composite attribute is something which can be divided, like name, first name, middle name, last name. It could be divided. The same name could be divided into three. Address, first line, last line, second line, street, city, something like that. So some attributes cannot be divided. Some attributes could be divided. So the attributes which cannot be divided could be called as a simple attribute, and which could be divided is called as a composite attribute. Similarly, there are some attributes which have only one value. Say, for example, gender, it could be only one valued, either M or F. Similarly, date of birth, it could be only one value. One particular date could be the value of DOB. Multi-valued, like one person could have more than one mobile number, one person could have more than one mail ID, and so on. Derived attribute is one attribute whose value could be obtained from already existing attribute. So, my example of derived attribute is like when I know the database of date of birth of one person, I can calculate the age. Or when I know the starting date of, date of joining of one particular employee, from which I can calculate the year of experience and so on. So those are called as derived attributes. So I will show how simple attribute could be represented. So simple attribute is represented with the form of oval, so which couldn't be divided, Aadhaar number, register number, and so on. So this address, the street, city, state, and country. It could be name also. So if it is name, first name, middle name, last name, initials, and so on. Multi-valued attribute. So you can have more phone numbers or more email ID. So it is represented with the double oval. And single valued is CGPA or date of birth, gender, all these things. Now, derived attribute is represented with the dashed oval. So experience, yeah, I told you earlier, experience could be calculated when you know the date of joining and date of resignation, or date of joining and the current date of working. And age could be derived from the date of birth, and so on. So this is how the entity relationship diagram begins. So we have an entity, we have different attributes for the entity. So these are normal simple entities. This is a multi-valued entity. This is a derived entity. This is a composite entity. So this composite attribute. I'm sorry. This is a composite attribute. So the composite attribute is again being divided into subcategory of attributes. So this is how the diagram is to be drawn in general. So when I talk about the student entity, the roll number, name, date of birth, phone number, age, address, all these things are attributes. So these are describing the particular student. The same information is diagrammatically represented here as a diagram. Now we learned what is an entity, what are attributes, and so on. So when we want to develop a database for a banking sector, first and foremost thing is we have to fix about the entity. Entity in the sense who is going to participate, what kind of action is going to take place over there. So it could be a customer, it could be employer, it could be a savings account, it could be about deposition, it could be about the loan, all these things. So initially the entity has to be fixed. After the entities are fixed, we will come across the different attributes that is going to be connected with that particular entity. Once the entity and the attributes are fixed, we are going to focus on the relationship. So relationship is nothing but or association, or it's going to be a connection between two entities. So consider two set, student and instructor. The relationship could be an advisor or a mentor or a counselor or just a teaching faculty who's going to teach that particular topic to that or a subject to that particular student. So it could be represented in this way: a student, an instructor. So this two entity is going to be connected through a relationship, advisor or a mentor or just a teacher. So entity could be represented with the form of a rectangular box, attribute through ovals, and your relationship could be through diamonds. And next one is when we focus on relationships, we have two constraints. One is mapping cardinality. What kind of relationship two entities is going to share? And participation constraint, what kind of participation that particular entity set is going to take part with that database. So one is mapping cardinality. There are 4 types of mapping cardinality: one-to-one, one-to-many, many-to-one, and many-to-many. See, one-to-one is every student is going to have one mentor. So every student has one mentor, that is one-to-one. One-to-many could be one mentor is associated to many students. One mentor is associated with many students. Many to many could be there are many instructors for many students. So one instructor is connected to one student, other instructor is connected to other student, and so on. So many instructors are connected to or different mentors for different students.